Okay, good morning. I know we're a minute or so early, but I'm going to take that minute of your time to do a little speaker selfie, if that's all right, because I normally forget at the end. So if you pretend it like it was a really good talk and you really enjoyed it, give me a thumbs up. Thank you. Okay, you can all go now. Please don't. So I'm Robin. I work for a company called Confluence. Who's heard of Confluence out of interest? A few? Okay, maybe you read my t-shirt. So Confluence are one of the companies that contribute to the open source Apache Kafka project. And we have our own distribution of Apache Kafka. We have a managed service for Apache Kafka, a Confluent platform. So who's using Kafka today? Okay. Who's using Kafka Connect today? A few. Who's using KSQL? You are. You are. That's cool. So this isn't actually about KSQL. If I get time at the end, I'll show you a little bit of KSQL because it's very interesting and exciting, I think. But today it's all about integrating databases with Apache Kafka. So getting data from your database, whichever kind of database it is, into Kafka, which people do for various different reasons. So people maybe want to get data out of their database into Kafka because they want to just simply offload it to somewhere else. And Kafka is a suitable conduit with which to do that. So you've got data in your transactional system. Maybe it's like a big, expensive red box or blue box or whatever particular vendor you've got. And it's expensive to do work on it there. So let's take the data from that and stream it over to somewhere cheaper to do analytics workloads on it, for example. So let's take that data from our transactional system and go and shove it to S3 or BigQuery or Snowflake or wherever we want to do our work, or HDFS and do it on premises as well. So Kafka's useful for that. You can use it as an integration point for numerous different databases. You stream your data in from different places. Kafka gives you the back pressure and the scale for doing that integration. And then you push it out to the target place or places that you want the data. Another reason people want data in Kafka is because they're building applications using Kafka, and they want to do stream processing using data driven by events that are maybe coming from an application or a service that they've written. But that service needs data from somewhere else. You've got events flowing in, you've got orders coming in, but you want to be able to look up information about that order. Who was the customer? Never mind it was customer ID 42, but what's their email address, where do they live, and so on and so on. And so you can join information using Kafka and using data from other places like databases. So Kafka, some people mistakenly think, is just like a message bus. It's just like messaging. It's like all those other messaging things. It's not. Kafka is this event streaming platform that gives you the capabilities to do messaging and pod sub show, but it lets you persist data, it lets you process data, it lets you replay data, it lets you use those events and consume them in multiple different places. So you can actually bring data in from your database and use that within Kafka to join as your events are flowing through. You can also use Kafka with data coming in from databases to kind of migrate from an old way of doing things to a new way of doing things. So you've got your big hairy monolith sat on top of your database, because we've always built things that way, and you can't go changing that monolith. That is built, it's fixed, it was built by someone else who's long gone, it was built by a third party, you can't change it. But the database you can access, and the database is where all those events are stored. That's where applications tend to store their state, like they used to. So stuff that happens in that application, it gets written to the database. Those events we can take out of the database and stream into Kafka. And now we can start building new services around those events. We can start saying, this application over here that we can't change, we want to move away from. When something happens in that application, we can take those events and we can now drive new services. An order gets created up here. We can't hook into that. It would be expensive to do that. But we can hook into the database. And now we can drive new processes which want to subscribe to a stream of an order got created. So I'm talking lots about streams of data here, streams of events. And databases are kind of like these lumps of static data. Hands up who's like a database type person, a DBA, a data engineer, whatever we call ourselves. Work with me here. You're all kind of like hardcore developers. I've got completely the wrong audience. Yeah, okay, I'll get my codes. So my background, I'm ashamed to admit, not ashamed at all, is building data warehouses, is working with databases, writing SQL, doing all that kind of stuff. And most people working with databases struggle to comprehend the idea of a database being a source of events. They see a database as being a lump of state. Okay, my applications write state. I do work in the database and it's state. It's a lump of data. But actually, all the data that we're working with actually originates as a stream of events. So I'm going to go into this a little bit now, and then I'm going to plug my second talk, which is at midday today, at 12 o'clock, where I'm going to go much more into the kind of theory around events and why they're so important. But in essence, everything that happens in our businesses is events, whether it's customers interacting with us, or customers buying things, or machines generating events and writing log entries. All of these are events, as are databases. The state is simply how we've decided to manifest those events, but they started off as events. And you can also get back from what you've stored in the database as state, and you can turn it into events. So you look at a table and you kind of kick it and scratch it and sniff it, it looks like a lump of state, but it's actually events. And there's this thing called the stream table duality. So let me explain. If you've got a bank account, you've got a table in the bank, and it is as simple as this. I've seen systems. It's not. This is a very simplistic way of representing it, but it makes sense. You've got a table, and you say, what's the balance for my bank account? Select star from table where account ID is 1, 2, 3, 4, 5, and it says the balance is 50 euros. And that came about because I put some money into the account. There was a deposit into the account. And then I got some more money. I put another 25 euros into the account. Now I have 75 euros. So select balance from the account. It says, well, the balance is 75 euros. And then I spend some money. And I say, select balance from account. It says, well, the balance is 15 euros. So on one hand, you have a table. Select from table where key. Select the state, select the value from the table for this given key. But that state came about because of the stream of events. So all you actually need is the log of events. Okay, this great quotation from Pat Helens: the truth is the log, the database is a cache of a subset of the log. And again, this is what I talk a lot more about in my talk later today. But databases, we can turn inside out, we can take the events out of a database, and we can stream those into Kafka. So let's look at how we actually do that. I talked about Kafka Connect briefly earlier. I said, hands up who's using Kafka Connect, and a few of you did. If you're using Kafka, and you're trying to get data from a system into Kafka, or from Kafka down to another place, you should probably be using Kafka Connect. And if you're not, you should have a good reason understood throughout the team why you're not. Because Kafka Connect is part of Apache Kafka. It's the integration API within Apache Kafka. And it lets you stream data in from systems upstream, like databases, like message queues, like flat files, like wherever else you've got data, stream it into Kafka, and then from Kafka, push it down to other places. And you can use it just to get data in, or just to push data out, or you can use it to kind of like just build these pipelines. Get data from this database, stream it into Kafka, stream it over there. Oh, but also stream it over there, because remember, Kafka persists data. So you can take the same data from the database, stream it into Kafka, stream it over to S3, over to Elastic, over to Neo4j, wherever we want to use that same data. And the great thing for me, in the minority in this room as a non-coder, is that Kafka Connect is just configuration. There's an open API if you want to go and write your own connectors, your own conversers, and so on, but you don't have to. It's there, done for you. If you want to go and write cool code, go and do that, but the integration piece with Kafka is a solved problem. That's what Kafka Connect does for you. So it works as a source, and it works as a sink. And the only actual custom technology piece in Kafka Connect is the connector plugin itself. So this describes how to get data from the source system, so a database in this case, and then it passes it on internally within Kafka Connect. After that, it's just generic pieces of the framework. So it then says, how am I going to serialize that data into Kafka? Because Kafka messages are just key value pairs. They're just bytes. Kafka doesn't care if it's JSON or if it's Avro or who knows what. It's just bytes to Kafka. So when you start building out pipelines with Kafka, when you start writing applications around Kafka, you need to think about how you serialize your data. And if you don't, at some point, you're going to wish you had. Because there are really good ways to serialize your data, and there are really crappy ways to serialize your data, and people don't always think this through properly. And lots of the time, people kind of like reach for whatever's easiest, or reach for whatever's kind of like most familiar and gives the fewest errors, and then they move on. But the thing about Kafka is the more that you use it, the wider its adoption becomes. Because people say, cool, I didn't realize we had a topic with this data in, a live stream of these events, I could use that. Oh, I could use that. And before you know it, your simple, I'm just writing something to get data from here to here using Kafka becomes, I've got this data from here, and 10 other people are also using that data. And some other people say, we've got the same data, we'll also write it. And you've got to have a way of governing your schemas, otherwise the whole thing gets very, very brittle. The brilliant thing about decoupling that Kafka enables, you kind of lose all of that because you start having to artificially couple all these things together again with humans. And emailing schemas around, or saying why is it just broken? Someone just did a change and didn't tell us. Let's have a change notification board, because that's fun, isn't it? No. So let's use something sensible like Avro, like Protobuf, which actually gives us a way of enforcing and retaining our schemas. So if you use Avro, then there's the schema registry as part of Confluent Platform, which enables you it gives you somewhere to store your Avro schemas, and it provides a serializer. So if you're using Kafka Connect, it simply plugs in. If you're writing your own Kafka producer, you've got the producer API, the serializer there for you. It works with KSQL, it works with anything writing into Kafka. And you pass it your message, it takes the schema, it puts it in the schema registry, and then it writes a nice small little compressed message, binary message into the Kafka topic. And then when it comes to reading the data, whether it's Kafka Connect pulling the data out, whether it's your own Kafka consumer, whether it's anything else, the deserializer library goes and fetches the schema, deserializes the data, and now you have your payload plus the schema, which is super useful. If you're building one of these pipelines to take data from a database and go and write it somewhere else, that somewhere else may well want a schema around it. Maybe it's from one database to another database, or from one database down to a document store, or somewhere that supports the concept of schemas, which most or lots of data stores do. So having that schema available is really useful. Kafka Connect also supports something called transforms, single message transforms. So this is when you have data flowing through, and you want to do a bit of light manipulation on that data. You want to drop a field, you want to rename a field, change the topic name, do little things like that. Single message transforms are perfect for that. So you don't have to say, I've got this massive wide message coming in from this upstream system, and I only need that much of it, and it's kind of it's super wasteful, it's super confusing for anyone wanting to use that data. You can actually say, at the point of ingest, the data comes in from the source system, it passes through the connector plugin, the transform then drops out the fields you don't want, it serializes it, and it writes it to Kafka. So we don't actually write all of that extra crap that we don't want into Kafka topic. Or it works the other way around on the sync process. You could read the full message out of Kafka if you've written the whole thing in, and then on the way out, you can say, just send these particular fields down to the sync process. So you don't have to write additional applications around it. And I know you love writing applications, but we'll write applications that do something else. Single message transforms do that piece of the transformation work for you. And as I said, it's all extensible. So it's an API, it's part of Apache Kafka. You can write your own connectors, you can write your own converters, you can write your own transforms. And you go and write them, go stick them on Confluent Hub. Or if you want to see what's there already and what technologies you can connect to, go to Confluent Hub and you can download and install them from there. So that's why you'd even want to get data out of a database into Kafka, and that's broadly how. The broad answer is Kafka Connect. Kafka Connect is almost always the answer to integrating systems with Kafka. But this talk isn't just about Kafka Connect. This talk is about getting data from a database specifically. So let's now actually have a look at how we're going to do that. And there's two different ways. Most people assume when you're getting data from a database that you're going to say, oh yeah, CDC, change data capture. But there's actually two different types of CDC. The one that probably most people understand it as being is this one up here, the log-based CDC, where we go against the transaction log in the database. But there's actually a different way of doing it as well. So the much simpler way is what I've called, or is what is generally called, query-based change data capture, which is where you basically poll the database and you say, has anything changed since I last looked? So you have a column, like a timestamp column or an ID column that you know is going to go up, and you simply say, select star from the table where this column is greater than it was last time. And then I just store the last time value each time I poll, and we can work out maybe what's changed. So we insert a couple of rows in the database, we do a select star where it's greater than the previous timestamp, and we get that data into Kafka. Some stuff happens in the database, our application or whatever is writing data, we do a select star from it where it's greater than, it says, well, that particular row there has changed, and we copy it across. That's broadly what Querybased does. So it's kind of simple to understand. We'll talk later on about the pros and cons of each. Log-based is what most people assume by the term CDC, and log-based actually uses the transaction log of the database. So all relational databases use the concepts of a transaction log in various different terms and various different kind of specific implementations. But this idea that when you do something in the database, you do an insert, you do an update, you do a delete, it gets sent to the transaction log and stored there and then flushed to the data files. The transaction log, which none of you are DBAs or no one will admit to being a DBA, the transaction log is what the DBAs hope and pray they've got. When the database goes bang, then they have to restore and roll forward what changed. It applies the transaction log, broadly speaking. So it was an insert, it was an update, a delete, we roll that forward and then we're back at where it was. So the transaction log serves a vital purpose. And we can hook into that transaction log and we can pull out the events from the database into Kafka. So we can do a snapshot of the database at a particular change point, and then we say, now we go to the transaction log, we get every single change, we make a change in the database, it goes across to Kafka. So, that's change data capture, sounds easy. Well, let's actually have a look what it looks like. I've put the code for this on GitHub, which I'll tweet prolifically afterwards if you'd like to see it. But, is that big enough? I don't know. Normally I have to ask that, it's like, this is a cinema screen, of course it's big enough. If I give myself a tad more space, is that still big enough? Yeah? Yeah? At the back, thumbs up if you can see it. Thank you. So, this is MySQL. It could be any relational database, it's just, I'm using MySQL because it's simple to use. And, can you see down here by the way? Or is my head in the way? You can see it, okay. We've got tables in the database. So we've got one called customers. I can say, well, tell me about this table called customers. And it says you've got various different columns. You've got first name, last name, email. We've got an update timestamp, which is going to be useful. And we've got some data in it as well. So here's my cheat sheet, because otherwise I'll start typing things wrong. And we've got 5 rows in the database. This is not a big table. But this is the kind of data that you would often think about bringing in to Kafka, because it's reference data. It's the kind of data you would want to use to enrich events that are flowing through your system. Or it could be sales data, you just want to flush that through for analytics, but in this case we're looking at the idea around enriching events that are flowing through Kafka. So we've got data in the database. Now we're going to create ourselves a connector. So Kafka Connect, let me switch over to this one. Kafka Connect, we just chuck some JSON at it. So here we're saying we would like to create a connector using the JDBC source connector. So the JDBC source connector lets us do query-based CDC. It's going to poll the database using JDBC, and it's going to go against this particular table here. Here we go, demo customers, and it's going to use the update timestamp column to try and work out what rows have changed. So we create that, and we say, has it worked? And it says, yes, it has. So we've got a connector here, it's a source connector, and it says it's running. So what we can do now is say, well, let's go and have a look at the data. So if it's the first time it's run, then that last timestamp is going to be null, or kind of like years and years and years ago, probably epoch 0. So it's then going to pull in everything from the database. So if we're going to have a look at the data, so I'm using Kafka Cat, by the way. So if anyone's a Kafka user already, and you don't know Kafka Cat, go and check it out because it's awesome. It's a consumer producer and it does fancy things. So here we've got a dump of what's in the database. Okay, we've got ID 1 is Bibi Agabright, ID 5 is Modesta Coltart. This is not live data, by the way, you'll be glad to know. So what we can do in MySQL, up at the top, so MySQL at the top, Kafka topic at the bottom, and you'll notice down here, it's not return control, so it's just waiting for any new messages to arrive on the topic. So up in the database, I'm going to create a new row. So I'm manually doing it. Normally it'll be like some application that works with the database is going to do an insert into the database. So I do an insert into the database, and down in the Kafka topic, we've now got the new data. Hurrah! This is good. So we can capture any change happening in the database, any inserted from the database we got it in the Kafka topic. But then we realized we forgot to specify their email address. So we're going to take their email address and we're going to update it in the database, and we get the new row down here, or we get the updated row down here. So first we captured the fact that we've got the new user and their email address is blank. And then this one, we've got the update and their email address has come through correctly, which is good. So the JDBC source connector, snapshot of the table, and it's going to capture the inserts and the updates. Now, let's go and have a look at log-based. So log-based CDC is going to get the transaction log. So this is MySQL, it's going to use the bin log of MySQL, it's going to take a snapshot, it's going to create the database, take a full snapshot, and then it's going to capture every single change that happens there and there. So let me clear that and create the connector. So this time, it's the same idea. We connect to Kafka Connect, we send it some configuration. Here we're using Debezium. So it's the Debezium and it's the MySQL source connector. There's how we connect to the database. We're going to pull in this particular table. It's kind of the same idea. It's just slightly different configuration each time, depending on the connector in question. So create that, and we say, is it running? This is yes, which is nice. So we've got a running connector, so it's done a snapshot of the database, and now it's going to capture every change subsequently. So let's go and have a look at the data in the topic this time. So this is a different topic that it's written to. And you'll notice the data is a lot different. So I've formatted it like this deliberately because what we get from the log-based change data capture is a lot more detail. When you do query-based change data capture, you're simply acting as a database client, select from this table with this predicate, where something's changed. Select from the table, it says, okay, here are the rows in the table as it currently stands. Log-based change data capture uses the transaction log to be out 10 minutes. I thought it was 45 minutes, Mark. Okay, I'll get quicker. Thank you. So, the log-based change data capture can tell you what the record was beforehand as well, because that's captured in the log. So here, this is just the create. So this is the snapshot. So beforehand, it doesn't know what it was, because it was just the snapshot of the database. Here's the record afterwards. But then here's other information. Here's like the SCN, the bin log, all that kind of stuff if you like it. And the operation, it was a create. So now, in MySQL, let's create ourselves a new row. So we're going to create a new row. And down here in the Kafka topic, you'll see it's done a create again. But then obviously we got the address wrong, so we need to update that. And in the Kafka topic, we've got this. It was an update. So you'll notice also that using log-based change data capture, you get the type of operation as well. Query-based is simply like, there's a row, there's another row, there's another row. Was it an update, an insert? I don't know. Whereas log-based actually knows what kind it was, and log-based can tell us, this is what it looked like beforehand, the email address was blank, and this is what it looked like after. The email address was this. So if you're writing a system that actually needs the events from the database, every single event, you now have access to what it was before and after. Not simply like something changed, maybe. You actually have before and after. And what you also have is when you realize that you've duplicated the data, you can say delete from customers, where ID is 43. And it says, okay, I've done that. And down in Kafka, it says, haha, we've got a delete. They've deleted a record from the database. If we go back up and we say before, that's the record that they deleted. After, well, it's null. The record's gone. So it's a good way of being able to capture everything out of the database and drive your applications from it. So let us crack on somewhat. So, which one do we use? Log-based, query-based? They're kind of like, I just want to get data out of my database. Let me cut to the chase, because, so is it past I have to finish? Yeah, 10:30. Yeah. Ah, right. 15 minutes questions. Fine. Okay. Does anyone object if I run over slightly and we have fewer questions and more talking?
Go for it.
Okay. Phew. Right. Deep breath. So, change data capture, which one do you want to use? It depends on what you're getting the data out for. If you're getting the data out to simply offload it from your database and you want to over there, you want to replicate, here's the current state of what's in the database, chuck it into S3 because we want to do some analytics or whatever, we just want generally what's over there in here, then query-based may well work for you because it's much easier to set up. You simply need your JDBC driver and you need permissions to select from that table. That's all you need. You don't have to go kind of like cap in hand to your DBA saying, please can you install this stuff. Select star from the table, that's all you need to be able to do. The trouble with the query-based CDC is that it doesn't capture everything, and it also polls the database. So again, DBAs, no one will admit to it. If you see an application continually hitting the database in a suboptimal way, you're not going to be very happy, because it's probably your production transactional database, and there are other users of that system. Probably your production transactional applications, the people will be saying, like, why is the database going slow? Well, there's this application over here that keeps on polling it every 5 seconds to see if anything hasn't changed, which may or may not be acceptable. So the query-based change data capture is going to keep on polling the database, and it also doesn't capture everything. It'll capture inserts and updates to an extent, and it won't capture any deletes. You also have to have a schema that supports it. You have to have a timestamp column that gets updated automatically when you make update changes to the table, or an ID column that keeps on going up. If it's an ID column that's going up like a customer identifier and you update that row, that ID is not going to go up, so you won't capture that change. So you have to think much more carefully about how you implement it. So the inserts, we capture those. The updates, we capture those. The deletes, we don't capture those. The other problem with it is that you don't necessarily capture every single change in the table. So if you're writing an event-driven application, if you're using this idea of migrating from a database supporting application over here to a new application over here, then you're not going to capture every single change, which may well be a problem. So if you think about this, we do a select from the table, we've got an orders table. So we've got an application writing orders to a table, select star from this table, it says, okay, we've got a row, it says it was order ID 42, it's shipped at this particular timestamp, brilliant. So we've got the row down there. But if you think about how that record was built up, first off, our application created it and it goes into state pending. Then our application makes another change to it. They add the order address to it. Then the customer says, oh no, I need to change the delivery address. They make another change to it. And they say, okay, we've got the shipping address. Now we can ship the order. So we've got 4 different state changes that have happened to that table. But all that we actually capture when we do a select, because it's within our polling interval. So if it's within a 30-second polling interval, we polled at like the top of the minute, we didn't capture anything, and then we poll again, we capture the final record. So we only capture that. We don't capture those other 4 state changes. So if you're writing event-driven applications, then you need to be using log-based CDC. Query-based is fine. Query-based will capture some things. It won't capture everything for you. So log-based CDC uses the transaction log. You do an insert, it gets captured. You do an update, it gets deleted. It doesn't get deleted, it gets captured. And you do a delete, and that also gets captured over into Kafka. So you might notice a slight similarity between the left and right sides of the picture here. Because both, if you kind of like squint a little bit and look sideways, both are built on the same concept. Both are immutable event logs. Except databases are kind of like so far abstracted away from that concept, but like, here's a SQL API. Kafka instead says, here's the immutable event log, let's make it distributed and scalable and highly fault tolerant and resilient. Now it builds cool stuff on top of it. You can use SQL if you want to, you've got KSQL, but you don't have to. Whereas databases are like, here's your SQL, and like, here's your transaction log that you've, like, no way can you access that. And yeah, I kind of suck at scaling most of the time. Whereas Kafka takes, kind of like, unpicks all of that stuff, which means that sometimes it's like, oh, this is a real pain to work with, but it also gives us great power to build different applications. So which tool are we going to use? If you've chosen, or you have to choose first, which method are you going to use? Are you using query-based, log-based? Query-based, Kafka Connect, JDBC source connector. Easy. Download it from Confluent Hub, go and get it off GitHub, do whatever you want to, add your JDBC driver, and off you go. If you want to do log-based CDC, it's not quite so straightforward. Debezium is a fantastic project. You've got support for MySQL, Postgres, Mongo, SQL Server, and I think they're looking at adding Oracle as well. There's various kind of like licensing things around that. Proprietary ones, a lot of the time, if you paid for your database, you end up paying for your change data capture option as well, for various different reasons. There's even options for getting data out of your mainframe as well. This is a kind of example of the kind of stuff you can do with it, of what I was talking about earlier, where you've got ratings coming in, you've got events coming in, which could be maybe ratings from an online web application. You can enrich each of those ratings that are arriving in the system with information from your database. And you can join those together and write it out to a target system. Should we do a demo, or shall I do questions? Demo. Let's do it. This is going to be interesting, because I only found out I was doing this talk the other day, and the demo I've not done for a while, so it could be you get to see a spectacularly failed live demo as well, which is always fun for the audience and sucks for the presenter. So, here we go. What we're going to do, I'm going to use something called KSQL. So, I know a couple of you said you've used KSQL. Has anyone, who's heard of KSQL? Let's do it that way. One, two, a few. Who's used KSQL properly? A couple, three, four. Oh, more of you. Brilliant. Welcome. So, KSQL it lets you do stream processing on top of your data in Kafka. So, it's not about ad hoc querying. It's not about like, I've got a BI tool, can I hook it up to my data in Kafka? No. KSQL is about writing stream processing applications for poor souls like me who don't write Java and so on. I want to write stream processing applications done in SQL. So I'm going to copy and paste a bunch of stuff just in the interest of time, and then I'm going to explain what I've done. So in KSQL, you can say create a stream on top of a Kafka topic. So stream is a Kafka topic with a schema. There's those schemas again. Schemas are kind of useful, right? Because I've said, here's my topic, and it's an average. So KSQL has gone to the schema registry, said, can I have the schema for that topic, please? And the schema registry says, here you go. Which means that when I say describe this stream, it says, there's your schema. There's your lovely schema. Because with a schema, we can now pick out columns from that stream, we can add predicates. So we can do things like select the user ID and the message from ratings. And it says that's not going to work. And you say that. So this is now going through that Kafka topic, picking out every single user ID, let's pause that so you can read it, with a rating. So this is the idea of the online web application, people leave ratings, your product sucks, it was good, more peanuts please, and so on. So user ID with a message. And it's a live stream of events. So it started off at whatever time, and it keeps on trickling in now. It's obviously a data generator in the background. So the data's just ticking over, it's arriving in the Kafka topic, being produced to by something. By our own microservice, by something else that's writing to a Kafka topic. We don't care how it gets there, it's just events in a Kafka topic. And what we're going to do is we're going to join to those events using our customer data. So if I say show tables, KSQL supports that stream table duality that I told you about. So in Kafka, show topics, what topics have we got? We've got a topic called ratings, we've got a topic called customers. Both of these are streams of events. Both of these are just Kafka topics written by whatever Kafka producer we're using. Happens to be one of them was Kafka Connect, one of them was a web application or whatever. They're just Kafka topics, they're just streams of events. And our ratings one, we've said we want to model that as a stream, because we just want to look at every single event as it comes in as a stream of events. Our customers one, we've said I want to model that semantically as a table, because I want to know for every key, user ID, customer ID, what's the value? Not kind of like, what are all the different changes? So like we created the user and then we changed their email address and then we did whatever, whatever, whatever. What's the current state? So what's the user's current email address, current whatever, whatever, whatever. And we can actually select from that. So we can say show tables, and it says you've got a stream, so we can say select star from the stream, and it's going to say here are all the changes, here's the Kafka topic with the schema added on top of it. So here's our user ID, here's our user that got created, then we changed their email address. So we could change that, say, where ID equals 43. So we created it with a blank email, and then we deleted it. Okay, sorry, we updated it. So you captured both changes. But if we work with a table itself, So customers table. So this is the same Kafka topic in the background. Same Kafka topic. It's just we're modeling it. We're telling KSQL, treat this as a table. Take those stream of changes and just give me the current state. This is the current state for user ID 42 is this. Okay? Should have done that with 43, shouldn't I? So the current state is this. Never mind what happened in the background, the current state is this. And if we go into MySQL and change it, that's getting confusing because I deleted the record. So you can see the changes coming through. So let's change their email address to something like that, because we're running out of time. So you can see the changes are coming through. So each time the state changes, it comes through. And if I do that, tell me what the current state is, it says it's that. So the table emits the changes in the state, it keeps up with the changes, but if you go to it and say, what's the current state, it says it's this. Which means we can then use it in a join. We can do this. That. And what we're doing is we're saying select the rating and so on from our events, our event stream, and they're saying do a left join out to the customers. This is just SQL, right? On the foreign key, primary key relationship, and just show me the first one. It says, okay, the full name is this. So user ID 1 left a message, they said it was brilliant, they said the airport refurbishment looks great. Who's user ID 1? User ID 1 is Bibi Agrawright. That's kind of useful to know. And if we do this, and r.userid equals 1, just show me the changes or the events for this particular user. We're going to get all of the reviews that Bibi Agrawright has left. And if we go into MySQL and make a change, and change their email address, so I've changed that in MySQL, the next one that comes through has picked up the new email address. So I made a change in the database, and the next event that arrived in Kafka was enriched with the latest version of that row from the database because it got streamed into Kafka. Okay, so that, somewhat speedily, is an example of that. Microservice or whatever, writing events into a topic, we want to enrich those events as they pass through Kafka. From KSQL, you can write back into a Kafka topic. So I was showing you just the console output there, but KSQL, you would write a stream processing application. You would say, take this query and write it back to a Kafka topic. So now we have a Kafka topic of ratings with customer information, which we can use to drive other applications. I've got an application that wants to know about ratings, and I need to know who the customer is. Option 1, I subscribe to the original rating stream, and then I somehow do lookups against the database. Sucks. I cache the database locally. Sucks. Oh, I could also use that enriched data as it passes through Kafka. That's nice and easy. Because that same enriched data, I might also want to write down to Elastic and do analysis on top of it. But you enrich data once, use it many different times. So, if you want to try it out, you can spin it up on Docker, like I've done on my laptop. You can go and try it on Confluent Cloud. You can try it for free there. Manage Kafka, you've also got KSQL on there as well, Kafka Connect and Schema Registry. If you want to learn more about Kafka, there are a few people who haven't yet used it. Those books are fantastic references. You can get them for free off our website. Scan your QR code, go to that URL. I'll try and remember to tweet it as well. So you've got various different ones. The I Love Logs is brilliant for laying out the theory and the fundamentals behind why a log-based system makes so much sense and why it's fundamentally different to what we've done before. Event-driven systems, Kafka, definitive guide for ops and everything about it. They're all really useful books. That's the end. There's no useful stuff on there. I'll put that slide back on there so you can take pictures of it. Apologies for overrunning slightly. I believe we've got 7 minutes. Yep. 7 minutes for questions. Yes?
Do you have experience in managing several hundred millions of events and then selecting the last state? Did you ever do this and some runtime statistics there?
So the question was hundreds of millions of events and taking the latest state and runtime statistics. I've not tried that myself, no. But KSQL is built on top of Kafka Streams, which is built on top of Kafka. So all of the scalability principles of partitioning your data and scaling that workload out apply, but specific metrics I don't have. Other questions? Yeah?
When would you prefer to use Kafka streams instead of KSQL?
Where would you prefer to use Kafka streams instead of KSQL? That's a great question. You lot, can you go and use Kafka streams because you're all Java coders? I'll be using KSQL because I can't write Java. That's one of the reasons. Another reason is that KSQL, even as an application developer, even if you live and breathe Java code, KSQL's sometimes just simpler. You don't have to write a bunch of boilerplates. You simply run a statement which says, I don't know, I want to repartition this topic. Create stream, whatever, with partitions equals this, select star from there, partition by whatever. Or I want to reserialize it. I've got a topic that's Java, let's say JSON. I want to reserialize it into Avro, select star from there, use Avro. So it's a lot simpler in some cases. Where you would drop down into Kafka streams is where you want some of the more detailed functionality that KSQL doesn't yet support. So there's some things which KSQL doesn't yet do that Kafka streams does. Or you simply prefer writing Java applications. There's not kind of, it's simply a higher level abstraction on top of it. There's also kind of a middle point, which is you can deploy user-defined functions in KSQL. So KSQL is brilliant because it makes stream processing available to a broader audience because more people know SQL. But if you've got specific functionality, like, I don't know, you've got a machine learning algorithm you want to embed within your processing, you can have your Java team write that as a UDF, deploy that in KSQL, and then access it through KSQL. Does that answer your question?
Yes, thank you.
Yeah.
So we have the real example that we are offering KSQL for data scientists. So we are using Kafka to transform the data and then offering to data scientists who are not able to program and write a stream.
Brilliant. Yeah. Okay, great. That's a good point. Yeah.
How does this, I think it's query block based, how does it feel when you have relations, so one-to-many foreign keys, and you do not get this flat result set?
So query-based, lock-based, how does it work in terms of when you have foreign keys and relations?
Yeah, so in my original database, the user has a one-to-many relationship to its address, maybe, and I get this.
Mm-hmm. So there's different ways around it. With the query-based, you can actually specify your own query. So I'll show you there, it's just like select star. But you could actually write your own query which resolved at the point of polling all of those relationships. And that can be useful because it's a common question and problem of how do I maintain my transaction boundaries across the systems. So if I'm simply scraping this table and that table, how do I know that the various relationships are satisfied? There's another approach, which is the outbox pattern, which Gunnar Marling, one of the Debezium developers, has advocated strongly for, which is where you build basically your payload on the database side, and then you CDC against that, which has then got the materialized payload that you would want. I've not expressed it particularly clearly. There's a blog post about the outbox pattern, which is worth looking at as well. Yeah.
Thank you for the talk. Small question. Is there any testing functionality for KSQL? So how do you,
yes, so
you never make mistakes, but...
Yeah, so the question is there any testing functionality for KSQL? As of 5.3, there's a test runner. So you give it a file which says, here's my inputs, here's my statements, here's my expected outputs. Go and run it. Does it succeed or fail? Last question. Anyone? Okay, thank you very much.